So, my name is Tim MacFarlaine. In my spare time, I work on a programming language called Tycho, which is a small extensible language on .NET. The main idea, or the challenge really, is to get the most simplest, most powerful language I can think of. And it's the idea is to have a small kernel that is extensible, and that starts off being pretty useless, but you can, because it's extensible, you can build it into something that is actually useful. So Tycho is functional, it's object-oriented, aspect-oriented, it's language-oriented, but most of all it's extensible. So you can do, if we missed a few oriented off there, then you can do that yourself. So I'll start off with a sort of simple kernel, and I'll start with the first thing. And the simplest things are variables. Variables come in two forms: proper variables, which can be assigned several times, and constants, which are defined once, and then they're constants, so you can't assign to them again. So here's a constant. And it also has functions, obviously. Functions are sort of similar to the C# lambda syntax, so you'd be familiar with that. We assign a function to a variable, and that gives it a name, and then we can call that function with that from that variable. Functions have several lines in them, and you can either use a bracket syntax with the braces, or an indented syntax similar to Python. Both amount to the same thing. And as you can see, it's sort of dynamically typed, so addition is it's different for strings or integers. We also have objects, and objects are they're literal objects, so that you construct objects on the fly. You don't construct objects from classes, so there are no classes. You construct objects at runtime, and you assign to a variable, and then you can start calling methods on them, or getting properties out of them. So objects have properties, getters, setters, multi-methods, indexes, the usual sort of crowd. There's a method call there. Objects are, so functions are closures in that they can use the variables in their lexical scope. But objects are also closures in that they can use the variables that in which they were defined. So they can use variables up a few levels of stack. So that's sort of one way of getting static variables for objects, is to use the variables up a couple of layers in the lexical scope. Now to create multiple objects, so as you would in a class-based language, you would use the new operator. Here we just create a function that creates new objects for each one, and so this is a biblical reference, just in case God thought that just one Noah wouldn't do, he'd have to make two of them. But
the backup?
Yeah, just don't tell them about each other. But objects are a sort of a specialization of a more general concept, which is actors. And actors are sort of the name comes from some of the research that came out of the actors model that Carl Hewitt et al. Did back in the 70s. And actors are a sort of model where you have dozens of, or lots of different little software components that communicate only by passing messages to each other in an asynchronous fashion. And it's a nice model for concurrency. But the idea is that each software component can respond to those messages in any way they wish, and they may do a dynamic dispatch to handle that, or they may just implement them in any way they like. In Tycho, actors are synchronous, so we're not trying to tackle the concurrent issue there. But here's like a simple actor, which is just printing off the name and the arguments of the method that was called in it. And as you can see, properties and methods, properties, indexes are all just method calls, and they all go through an actor. So actors can be used to build your own object models or object systems in the sort of theme of the art of the meta-object protocol, or just provide an aspect-oriented mechanism. So you can basically intercept message calls or method calls. So the usual stuff: security, persistence, software transaction memory, that sort of thing can be implemented with actors. So they're pretty good generalization of objects that you can do interesting things with. The other thing that Tycho has is schemas, and schemas are a way of validating objects as they're passed into method calls. Or you can use schemas just to validate objects, that they have a certain form or a certain structure. And there are structural typing at runtime, effectively. There's no static type analysis going on here. It's all at runtime. But schemas also do pattern matching stuff. So if you use Haskell or ML, you'll be familiar with the pattern matching qualities of those. So here's two methods. The first get area is calculating the area from a rectangle, and it's doing that without pattern matching. The second one with pattern matching, and it sort of makes it a little bit easier to read and a bit easier to use. Obviously, as objects become more complicated, pattern matching gets more and more useful. Here's a multi-method that has several implementations, each one for the different cases of the Fibonacci sequence. But we couldn't be extensible without having syntactical macros. And here's an example of implementing the ++ operator, as you see in C# and C++. And so it effectively just rewrites the ++ expression into expression equals expression +1, and then just does that in line. But it's hygienic macros, and coming soon we have lexical macros as well. So lexical and syntactical macros are in the same framework, and that's all the way down to the character level. So you can write your own tokenizers or token syntax. So it's sort of handy for writing DSLs that might, so for example, template engines that cross two different syntaxes in the same file, for example. And obviously we've been growing Tycho with these syntactical macros, so kind of bootstrapping it, and so that's sort of growing the language in a technical way is quite straightforward in a way, but there's sort of, you've got to ask a question like how does that work out in a political sense? How do you grow a language in a community and keep them all together, agreeing on the same things, which is something I'm not going to go into. And that's it. It's just a really very short introduction to Tycho. So, any questions?
Inheritance?
Sorry?
Inheritance?
Objects are kind of flat in structure. They don't have, they're loosely, sorry?
I mean, it's not class-based, for understand object-oriented. It's maybe like JavaScript prototype-based?
Yeah, it's under the hood, it's prototype object-based, but I chose not to present the prototype system to the user. And objects are kind of flat in structure. They don't defer to other objects as in an inheritance structure. They do have, as I said, it's sort of prototype under the hood, and there's a basic root object that handles all missing method calls, and you can extend objects using that scheme.
Any thought of tackling the full asynchronous actor?
you can implement asynchronous actors with this in that you do method calls that return nothing initially, and you pass in the receiver. So you know technically you could do that, but from a programming in the small environment, I think the concurrency is just a bit too much. Yeah.
What was your reasoning behind doing this language? I mean, what drove you to do this?
Fun, mostly.
That's a great reason.
Yeah. I mean, I'm sort of curious. I've been looking at programming language for sort of a decade and just wondering what I could, you know, if I was going to do my own, how would I do it? Yeah.
A couple of questions. How many committers and what version?
0.2 and one other committer. So it's kind of early days. It was open sourced about 4 months ago. I've been working on it for about 18 months.
Have you compared it to Ioki?
Ioki?
Ola Benning's language?
No. Okay, I'll have to get the link off you.
Yeah, offline we'll talk.
Yeah.
What language? Were you asking
Ioki.
Ioki.
Ioki?
Ola Benning's.
IOKE.
Yeah.
Anyone else?
So what does, can you consume other objects like defined in C#, for instance, since you're targeting the CLI?
Yeah, so you can go into the .NET framework and you can use all of the .NET framework as it is.
And how does that look like from here?
So I'll go back to the object slide. I mean, it looks like that. I've translated all of the .NET names to the sort of lowercase hyphen thing, so it all looks consistent. But you know, that's a matter of style, I think.
What's the largest sample program you've written with this?
My sample programs are pretty short. I spend most of my time writing the compiler backend, but Matthew Wilson has written several hundred-line programs that work. So, yeah.
Did you write this on the CLR, or did you write it and report it to the CLR?
I wrote it. It's not compiled to the CLR. It's written in C#. It's compiles to a bytecode interpreter, toy interpreter that is embarrassingly slow. But we're planning to put it on the DLR pretty soon. Yeah. Okay. Thanks for watching.